Okay, the next thing we want to talk about is, well, what about when my line crosses the intercepts? Okay, when my line actually crosses the axes. Intercepts of my line are the actual points, if there are any, where the graph crosses or just touches the x and or the y-axis. Okay, so let's look at this line down here. We're looking at this line and we can see that it is crossing the x-axis right here at that point. And we can count that point. We can say that's 1, 2, over 3, up 0. So it crosses the x-axis at 3, 0. We call that the x-intercept. The other point where it crosses on our graph up here is here at over 0, down -2. Okay, so we have the point 0, -2, and this is what we call the y-intercept. I want you to notice that in each of these points there's a 0. For the x-intercept there's a 0, and for the y-intercept there's a 0. And that's because that's the point that we've got where it crosses the axis. And we had two intercepts over here. It crossed the y-axis and it crossed the x-axis. What do you notice about this line over here? I notice that it's a vertical line going straight up and down. I notice that it crosses the x-axis right here at -2, 0. That would be the x-intercept. But there is no other intercept, is there? There is no other point where it crosses the y-axis. In other words, this line right here is traveling parallel to the y-axis and it's never going to touch it. So over here I only have one intercept. This is going to be useful for us whenever we're graphing a little bit later on also. Now, how do we find the x and or the y intercepts? Well, we can do it by a picture or we can do it algebraically. And now we're going to do it algebraically. Let's say, for example, I want to find the x and the y-intercepts of this linear equation. Remember, it's raised to the first power here and the first power here. It's a linear equation. I want to find what the x-intercepts are for this. The first thing I need to do, I'm going to find the x-intercept. So I let y be equal to 0. So for the x-intercept, I'm going to let y be equal to 0. And I'm going to solve for x. So take my equation, 2x minus 1/2 times 0 is equal to 3, because I'm letting y be equal to 0. So I get 2x is equal to 3, x is equal to 3/2. I'm going to rewrite the solution to be 1.5 or 3/2, whichever you want, 0. 1.5 or 3/2 was x, and y is 0. Okay, so I found out what the x-intercept was, and now I'm going to find out what the y-intercept is by doing the opposite. This time I'm going to let x equal 0. Okay, so I say 2 times 0 minus 1/2 equals 3. -1/2, y equals 3. So if I'm multiplying by 1/2, I'm going to divide by 1/2, which is really like multiplying by 2 over 1. So I need to multiply by a -2 and a -2, and I get y is equal to -6. So here I can write my solution or my ordered pair to be 0 for x and -6 for y. Okay, and that answered this question. So I can do it. I can find intercepts by evaluating or by looking at a picture, or I can find intercepts algebraically by substituting in 0 for x and then y. Okay, now let's graph those points. I've got 2 points here and here, and we're going to take a minute and we're going to graph them on my line, on my graph down here. So since I can see this right now, I'm going to use 0 and -6. Over 0, down -6. 1, 2, 3, 4, 5, 6. It kind of goes off, but we get it. My other point was 1.50. So I'm going to go over 1.5 and up 0. So that is my other point for this line. And now let me graph it. Let's see if I can get it to go through. I think I did. Kind of jumps around on me on this screen. There, that's going to be good enough. So I have a line that crosses the x-axis at 1.50, and if I extended that down, it would cross the y-axis at -6, at 0, -6.